to Isifedu blog. My name is Samson, aka Igwe. If today is your first day of coming across this channel, you can hit the subscribe button. You can also visit the past question session to download the past question and their various solutions, both the WAEC, JAM, and screening tests for various schools. I'll be taking you guys on chemistry, and today we'll be talking about a topic that is called hybridization. The topic is hybridization. So when we are talking about hybridization, we are talking about the combination of two or more orbitals to give a new set of orbital called a hybrid orbital. In other words, hybridization is the blending or mixing of different atomic orbitals to give a new set of orbital called hybrid orbital. Of course, you know what is an orbital, a region or a space in an atom where there is a maximum probability of finding electron. So we have the S, we have the P, we have the D, we have the F. So under the S, we only have S orbital, but under the P sublevel, we have the Px, we have the Py, we have the Pz. So these are the orbitals of P. When the S orbital mixes with any of these orbitals, that is hybridization. So when we are talking about hybridization in a layman understanding, it simply means atomic orbital plus another atomic orbital. Then it will give a hybrid orbital. Hybrid orbital. So this concept is what is called hybridization. It is just the combination of different atomic orbitals, then you generate a new set of orbitals. Like we have the S orbital. S orbital can mix with Px, it can mix with the Py, it can mix with the Pz. So in this case, we will have one S mixing with 3P. We call it sp3 hybridization. So these are the orbitals mixing together, and this is the hybrid orbital. This is the hybrid orbital. These are the orbitals combining together, and this phenomenon or process is what we refer to as hybridization. So one of the type of hybridization is the sp3. We also have another one when we have s orbital blending with px, blending with py. In this case now, the hybrid orbital will become sp2. That means one S is mixing with P and another P. We have two P mixing with one S. That's why we call it sp2 hybridization. So in this kind of hybridization, the Pz orbital is not used for the hybridization. And we also have another one that is S mixing with Px alone. So at the end, it will form sp. In this case, it's only S orbital that mixes with Px. The Py is not inclusive and Pz is not inclusive. So that takes us to the types of hybridization. Basically, we have three, though in further studies we have more type of hybridization. But in O level, we focus on the three types, which is the sp3, the sp2, and the sp hybridization. So having known what is hybridization, that is the mixing of atomic orbitals to generate a new orbital. So we will now go straight to the types and the explanation of the hybridization. So we have the types of hybridization. Basically, like we said, number one is the sp3 hybridization. We have the sp2 hybridization, and we have the sp hybridization. The meaning of this is that only one s orbital mixed with 3p orbitals, the px, the py, and pz. But here now, only one s orbital mixed with px and another orbital, py orbital. So here now, only one s orbital mixed with px orbital. And we say that carbon can undergo hybridization. Carbon, which is an element in the periodic table, can undergo hybridization. Carbon, which we know the atomic number is 6, it can undergo hybridization. But for carbon to undergo hybridization, something must happen. You know, there are two ways an atom can be. It can be at ground state, it can also be at the excited state. So before carbon can undergo hybridization, it must be at its excited state. Because when it is at ground state, hybridization is not possible. And we say that it is at the excited state when electron has been promoted from the 2s orbital to the 2pz orbital. What do we mean by that? The excited and ground state of carbon is this. Ground state. The electronic configuration is 1s2, 2s2, 2p2. Then excited state. The electronic configuration is 1s2, 2s1, 2px1, 2p1, 1, and 2pz1. So we are saying that for carbon to undergo hybridization, it must be at the excited state. So when carbon is undergoing hybridization, this is the state it is using. But here, hybridization is not possible. The reason is because all the electrons are still paired, it's not excited. But in this case, excitation has taken place in the sense that one of the electrons that is in the 2s has been promoted to the pz, the 2pz orbital. So for hybridization to take place, the carbon must be at its excited state. So we now go to number one type of the hybridization because we are giving the condition for hybridization to take place. When a carbon is having electronic configuration of this, it cannot undergo hybridization. So for hybridization to take place, this must happen in carbon. Having known the condition, we will now go to the types. Number one of it is the sp3 hybridization.